Hi, in this video we want to talk about similarity and congruency. So similarity and congruency have something to do with our triangles. Now, similarity refers to when two shapes, not necessarily triangles, but when two shapes have the same proportions, so they are proportional to each other. One can be a bit bigger or smaller than the other. But at the end of the day, if they are proportional, then we say those two triangles are similar in that regard. So for similarity, there's a condition that needs to be met. All angles need to be the same. So that means this angle must correspond with that angle. This angle must correspond with that angle. And then lastly, this angle should correspond with this angle. And this is the only rule that is needed to prove similarity. If we're to prove that ABC and EFG are similar, then we would say that triangle ABC is similar to triangle EFG. And notice the way that this triangle is named. A corresponds with E because they are equal. B corresponds with F because they are equal. And then lastly, C corresponds with G because they are equal as well. So whenever you're given two triangles, always pay attention to the naming convention, because it might just be that those are the angles that are equal to each other should you have to prove similarity, and they name the triangles for you. So that is similarity, and similarity has a lot of applications in Euclidean geometry, especially when we're talking about proportions and parallel sides. It gets very deep into this because you can be told that A, B, C, D, E. So here we can clearly see that ABC is similar to ADE because they share a common angle, and then this is equal to that because of corresponding angles. Similarly, we can say the same for C and E. They will also be equal. So if they're similar, it means that we can adapt these rules. AB over BD is equal to AC over CE. Right? Which is also equal to BC over DE because they are proportional. Their sides are proportional, therefore we can equate them this way. We could also say that AB over AC is equal to AD over DE. So as long as you're taking sides that are corresponding with each other, here we are saying AB over AC, so these two sides of the triangle are equal to AD over AE, which are the corresponding two sides of the bigger triangle. So just as long as you're working with that logic, you should not make a mistake. Just don't get confused when you're given a ratio and mistake it for a value. Whenever you're given ratios, always assign a variable to them. So should they say that AB as to BD is in the ratio of 2 as to 3, then that would be 2x as to 3x, because we know whatever it is, there will be multiples of each other. And yeah, so that's about it for similarity. As for congruency means that the two triangles or the two shapes that you're working with are exactly the same, which means that in order for congruency to be achieved, we need all sides to be equal. So all corresponding sides need to be equal. So it means if I have A, B, C, and D, E, F, AB needs to correspond to DE, and they need to be equal. AC with DF, and then lastly BC along with EF. When you can prove this to be true, then you can say for sure that these two triangles or these two shapes are congruent. And the way you can prove congruency, you can either prove that all three sides are equal, or you could prove that two sides and one angle are equal. Because if two sides and one angle, maybe let's say this one, are equal, then there is no way that this can have a different length to BC. They automatically have to be equal, because if these are equal to each other and the angle at which they part is the same as the other triangles, then automatically the third side needs to be equal to the third side of the other triangle. And that is similarity and congruency.